Hi, I'm William, reporting for the Fun Robotics Network. I'm here at the Southern Cross Regional with 5584 IC Robotics. They have an awesome slanted elevator, an amazing human player intake, and an incredible climb system. Learn about their software, all on Behind the Bumper. So, going from the start of the season, what was your strategy?
So from the start of the season, we knew we wanted to keep it simple, and so we decided to go with a coral-only bot and just to descore the algae from the reef. So to do coral-only, we knew that we needed an elevator to lift upwards, and hence you can see the angled elevator here. So we chose an angled elevator because it can reach horizontally as well as vertically, meaning our L4 scoring is extremely consistent. So as you can see, it goes up and extends, and it also means that we can remove algae from the reef very consistently. We also knew from the start we needed a deep climb to secure that RP and also get 12 points every single match, so this is our deep climb mechanism.
So starting from your where you pick up the coral into your station, could you explain that?
So basically our human player feeds the coral from the coral station into the chute. This chute has motors that will run and feed it into the end effector where it will get hit by it will break one of the photoelectric diffuse sensors and start to slow down before hitting the second one and completely stopping to align with to move the elevator up. And then once we're in position, we'll raise the elevator up and then feed it all the way through so the coral gets scored.
So yeah, I've seen throughout the comp, you've been able to take algae off of the reef while you're scoring. How does that overall work?
Well, we've got a algae wheel that just sticks out. It's just at the start of the match, we'll raise the elevator, it will fling out, and then it will spin with the end effector wheels and hit the algae when lined up, and it will just take it out.
So another question is, how do you ensure that the coral from the human player station goes into your overall end effector?
So we make sure that our coral is in our end effector using these photoelectric diffuse sensors. So we have two. So this top one just slows down our intake and end effector once the coral comes in, and the second one is a stop to stop the end effector once it reaches there. This also makes sure that our elevator doesn't lift too early, as if our top line break is hit but not our bottom one, we know that the coral might be somewhere in between and it's unsafe to lift our elevator.
So moving from your elevator, so how is it overall? How is it a cascade or is it a continuous type of elevator, and why did you choose that?
So we chose to do a chain-driven cascade elevator this year with 2 stages, and it is driven by 2 falcons on a 4:1 ratio. So we chose chain because it's very durable and very resistant to impacts and such. We did explore continuous elevators, however we ended up going with the cascade just because of its position control.
This is a really fast and quick elevator, and it makes sense how you can score so fast. Moving on from the elevator and the intake, how does your overall climber system work, and how reliable and how quickly does that climb go ahead?
Our climb is an iteration or a different type of every bot climb. It uses a 600-to-1 ratio from the neo vortex to the rotation on the climb. We also have a latch mechanism, so then after the robot's been deactivated, the elevator can still stay up. In here, once the climber activates, so normally when the climber is stowed, the latch is pulled back, and then as the climber comes up, the latch flicks out, stopping the elevator from going down all the way, even when it's deactivated. Yeah.
So yeah, I know there's obviously a lot of software that goes into this. What are some of those software protections that you've had to implement to try and make sure nothing breaks?
Yeah, we have quite a few software safeties on this. Namely, I think, is we don't use a single encoder across the whole robot. To zero all of our subsystems, we use current sensing, because we've had a lot of issues with encoders in the past. We also use our line brakes in here to prevent moving the elevator when the coral is either out of place or not in the robot. We also have an anti-tip on the robot. So if our robot tips too far, if we accelerate with the elevator up, the elevator will automatically bring itself back down to stow, which stops us from tipping over. It's helped us a lot in a few matches so far. Yeah, it's been good.
Another question is, what are some of the localization that you guys do to get a consistent, reliable auto?
For vision this year, we run 2 Ardu cams running off a single orange pie in the back of the robot. And we don't run a 3D pipeline this year. We've decided to only do 2D align, which only aligns with the reef in autonomous. For teleoperated, we're entirely driver controlled. We do keep a 3D pose, but it's rare that we use it, and it mostly only exists for autonomous stuff.
This is just a really awesome, just incredible design. And the last type of question I have is, I see that you have this aluminium chassis. Why did you choose to go with that one?
So from the start of the season, we knew that robots were going to get very tall, and there would be lots of tall robot syndrome, where robots tend to tip over when they're trying to score on L4, and so we knew we needed to have a very low center of gravity. To do this, we used a 3mm aluminium belly pan, which is not pocketed at all. So it's a solid belly pan all the way across, and that means our dry base is 23 kilograms, meaning more than half our robot's mass is at the bottom. So this has prevented us from tipping once this season completely, so we've never actually tipped over, and it is extremely robust. We've had plenty of impacts, and we haven't reached a single, issue from that.
I do have one other question. Is what are some of the further improvements you would want to take to this robot if you advanced?
So we've been looking at the strategy, and we definitely think that algae will be the separator for future competitions. So we have discussed possibly adding a way to capture algae and score it. We've also looked at having automatic alignment using the 3D pose so that the drivers have a much easier time for scoring.
Thank you so much for sharing this incredible robot. I can't wait to see how it overall performs here. And thank you very much. This has been 5584 IC Robotics.